Namaskar friends, I welcome you all in this class of mathematics. So, today we are going to discuss principles of counting. This is very important chapter of mathematics for you, and it is used very widely in almost all branches or disciplines because permutations, combinations and all sorts of groupings come under this chapter, principles of counting. How do you count? So, let us start. There are two fundamental principles of counting. Number one is fundamental principle of multiplication. We call it in short FPM. What is this? Friends, suppose you have to complete n number of jobs. So, suppose the first job, n jobs are to be completed. So, how many ways these n jobs can be completed? Suppose that first job can be completed in m1 number of distinct ways. Distinct way means that different ways. No one is common. There are m1 number of different types of ways you can complete this first job, and each one is independent. Now, the second job similarly can be completed in m2 distinct ways. Now, you can go on writing third job m3 distinct ways, and the nth job, total n job are there. So, nth job can be done in mn distinct ways. So, in total, if a question is there that in how many ways these n jobs can be completed. So, this fundamental principle says that this n jobs can be completed in M1 multiplied by M2 multiplied by M3, M4 till Mn. So, this is the first fundamental principle of multiplication, that if there are n number of jobs and each job is being completed in different number of ways, distinct ways, not common ways, then we take multiplication of all the distinct ways, and this will give the total number of ways in which these n jobs can be completed. Okay. So, let us take an example. Suppose you go to a shop to buy a pen and a pencil, and you ask the shopkeeper to show you the pens, and he shows say pen, 10 types of distinct matlab they are not similar, distinct pens. You choose one of them, then you ask for a pencil, and he shows you 15 types of distinct pencils. So, according to fundamental principles, how many ways you can select a pen? Out of 10 types, you will select only one pen, but your options are 10. So, you can select in 10 number of ways the pen, and again you have to select a pencil also, that you can select in 15 different types, distinct types are there. So, 15 number of ways. So, if we have to select a pen and a pencil, so then the total number of ways in which you can select a pen and a pencil will be 15 into 10, that is 150 ways. So, you see 150 options, which seems to be very simple, because you have gone to a shop and you have chosen one pen out of 10 distinct pens, and you have chosen one pencil out of 15 distinct pencils, but you know you have total options of 150 ways. Out of that, you have selected one pen and one pencil. So, this is the type of use. You can see that though it may not take much time, because out of 10 you selected one, and then out of 15 you selected one, but the total number of options were 150. So, out of 150 you have selected two things. Now, let us come to the second fundamental principle of counting. So, this is the fundamental principle of addition. This was multiplication, where you there are n jobs to be completed, and each job were done in different number of distinct ways. So, it was simply the multiplication of all m1, m2, mn gave the total number of ways you can accomplish the n jobs. Now, suppose the second one is fundamental principle of addition. This we call FPA. Suppose there are one job is to be completed out of n jobs. There are n number of jobs, out of which one job is to be completed, any one. So, suppose the first job can be done in m1 number of distinct ways, second job can be accomplished in m2. These are the alternatives, okay. m1 number, but all distinct, not the same. m2 number of distinct ways, nth job can be done in mn number of distinct ways. So, what does this fundamental principle of addition says? That the total number of ways in which one job is to be done out of these n jobs will be equal to m1 plus m2, this will be addition, plus m3 till mn. You just add all the distinct ways in which the n jobs can be done, and one job is to be completed, then its sum will be. So, this is the fundamental principle of addition. So, there are two principles of fundamental principles of counting. One is the fundamental principle of multiplication, FPM, and the other one is fundamental principle of addition, FPA. Now, let us take an example of FPA. We have seen example of FPA. Now, again take the same example. Suppose you have gone to a shop and you have to select this time you want to buy either a pen or a pencil, okay? Either a pen or a pencil. So, options are, the shopkeeper has shown you 15 distinct type of pencil, and 10 distinct types of pens. So, out of these you have to select one, either a pen or a pencil. You are just going to buy one thing out of these 25 options. So, this will be equal to 15 plus 10 is equal to 25. This is quite simple to understand. You have 15 types of pen, okay, and 15 types of pencils and 10 types of pen. So, there are 15 options here, 10 options here. So, total 25 options. You can choose either one of the 25. So, there are 25 options. So, you can choose 25 number of ways. But you see, you can see that in choosing there is a huge difference. There you had 150 options when you choose one pencil and one pen, and here it was only 25 options. So, it is difficult to comprehend. I will take another example which will explain you that how these things, though you might have learnt it in your school also. If you have taken mathematics at +2, this might be there, but don't worry, it is quite simple concept. Suppose 5 letters are there, A, B, C, D and E, and again 5 numerals are also there, 1, 2, 3, 4, 5. So, if suppose let us say a simple password is to be made, either you can write a letter, choose a letter or a numeral, one thing. So, how many options do you have? You can choose any of the letters from here. So, 5 options are there, and then you can choose any one of the numerals from here. So, 5 options are here. So, you have to choose one option. So, FPA says fundamental principle of addition, that the total number of options you have or total number of ways you can select is 5 plus 5 is equal to 10. So, it is quite understandable that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, out of these 10 options, you have to choose one options, those there are 10 number of options. Suppose it is said that choose one letter and then one numeral. So, such that A1 or B2 or A3 like this. So, then what will you do? You have 5 options here. You will have to use fundamental principle of multiplications. You have 5 options to choose a letter and then 5 options to choose a numeral. So, it will become 5 into 5. So, it will become 25. So, here it was only 10 options, here the options has increased to 25, which you can see that options will be A1, A2, A3, A4, A5 again, B1, B2, B5 and similarly E1, E2 and E5. So, 5 into 5, this will constitute the 25 options you have, whereas here you had only 10 options. So, you can see that in fundamental principle of addition, you have you just sum up the things and let us take another example. In fundamental principle of multiplication, you multiply the things, so the options becomes manifold. Suppose there is a class of students in which 35 girls are there and 40 boys are there. Now, suppose that event has to be done in which one girl and one boy has to be selected from the class. So, how many number of ways this can be done? One girl can be chosen out of 35 girls in 35 number of ways. You can choose any one girl, and one boy out of 40 boys you can choose 40 number of ways. So, if you have to choose one boy and one girl, fundamental principle of multiplication says that it will be 35 into 40 and this will be equal to 1400. So, suppose another event is there in which only one student is to be sent, either girl or boy. So, one girl can be chosen in 35 number of ways, one y can be chosen in 40 number of ways. Any one of the student is to be chosen. So, the total number will be equal to 35 plus 40 is equal to 75. So, you see the difference. If a boy and a girl is to be chosen, number of ways is 1400, and one student out of these, there are 75 options, 75 number of ways. Now, before going into the permutation and combination, I will tell you something about factorial. Factorial notation and its calculations. Factorials. So, the multiplication of first n natural numbers, that is sorry multiplication of first n natural numbers. We represent it, call it factorial n. It is also denoted like this also, which is 1 into 2 into 3 into 4 till n. Okay. So, this is denoted by factorial n. So, let us write it in the reverse order. It is written n into n minus 1 into n minus 2 into n minus 3, 3, 2, 1. So, this means that we can also write it as n into factorial n minus 1. You see, because this is n minus 1, n minus 2, n minus 3, according to this definition, this will become factorial n minus 1. We can also write it as n into n minus 1 into factorial n minus 2, because the rest of the brackets from here n minus 2 to 1, this will be equal to factorial n minus 2, and so on. We can go on writing n into n minus 1 into n minus 2 into factorial n minus 3. You see, this is a very useful notations and it will be used widely in this method of counting which will come in later class, permutations and combinations. Let us take some examples of permutation of factorial. So, the example of according to the definition, factorial 0, we define it as is equal to 1. So, if somewhere factorial 0 is coming, it will defined as 1. Factorial 1 will also be equal to 1. Factorial 2 is equal to 2 into 1 is equal to 2. Factorial 3 is equal to 3 into 2 into 1, which will be equal to 6. Factorial 4, similarly you can go on, 4 into 3 into 2 into 1, which is equal to 24. Factorial 5, you can write it elaborately or you can write 5 into factorial 4. So, this will be equal to 5 into 24 and this will be equal to 720. Okay. Now, let us take few more examples on factorial. It is very simple. Suppose in somewhere comes factorial 4 into factorial 3, it is very simple. It would write this will become 4 into 3 into 2 into 1 multiplied by factorial 3, 3 into 2 into 1, simple multiplication. So, 24 into 6 will come 144. Now, simple calculation. Suppose comes out to be factorial 10 divided by factorial 8 into factorial 3. So, this will be equal to, we can write 10 into 9 and again it will go into 8 into 7, but I will write factorial 8 here because in the denominator factorial 8 is there. So, it will be cancelled out, divided by factorial 8 into factorial 3. So, this factorial 8 will be cancelled out by this one and this will be equal to 10 into 9 divided by factorial 3, that is 3 into 2 into 1. So, this will be cancel out 3 and then 5. So, this will be equal to 15. So, this is very simple calculation. I have just explained so that there should not be any confusion. Just as we do the calculations of other things in factorial also, we should remember the definition of the factorial, and then we can expand the factorial, we can write the factorial in other factorial terms, and we can cancel out also it if the in the nominator and denominator the same factorial is coming, we can cancel it out. So, similarly, the summation and difference of the factorial, say factorial 5 minus factorial 4. So, simple, you can do it anyway. 5 factorial 4 minus factorial 4, and you take factorial 4 common. So, it will be equal to 5 minus 1. So, it will be 4 into factorial 4, which will be equal to 4 into 4 into 3 into 2 into 1. So, this is equal to 96. Yes. Again, suppose another example. We have a number in multiplication that is equal to 6 to 12. 6 into 7 into 8 into 9 into 10 into 11 into 12. So, we can write it starting from 1 to 5. We multiply in the denominator also and denominator also. So, this will be equal to 1 into 2 into 3 into 4 into 5, and then we will continue here into 6 into 7 into 8 into 9 into 10, and then in denominator also we will write 1 into 2 into 3 into 4 into 5. So, what essentially we have done, that we have multiplied 1 into 2 into 3 into 4 into 5 in the denominator, in the numerator and denominator. So, the result will be same. So, this will become, the numerator will become factor 12, because from 1 to 12, and this will become factor 5, factorial 5, sorry, factorial 12 and factorial 5. So, this multiplication we can represent in this factorial form. Okay. Suppose another example is there. 3 into 6 into 9 into 12 into 15 into 18 into 21. So, this can be written, you see you take 3 everywhere coming repeatedly. So, 3 into 3, 1, 2, 3, 4, 5, 6, 7. So, 3 to the power 7 we have taken out, and then within bracket it will be 1 into 2 into 3 into 4 into 5 into 6 into 7. Why we are doing so? Because I can see this is the, these are the multiples of 3. So, we have taken 3 outside, so that within this we will get factorial 7. So, just to write in the form of factorial, I have used this. So, anything written similarly in the form of 2n into 4n into 6n into 8n. Again here we can take 2n is everywhere 1, 2, 3, 4, 5. 5 multiply 1 into 2 into 3 into 4 into 5. So, this will be 2n to the power 5 multiplied by factorial 5. Suppose one more similar example. Problem is that this multiplication is there now. How to represent it in the factorial? So, we can write it from 1 to 8 we can multiply in denominator. So, we can write factorial 8, then comes 9, then I multiply it here by 10, in denominator also I will multiply. So, here also factorial 8 I have taken, and then into 10, here 11 will come, but 12 is not there. So, I will multiply it by 12, and here 12 will come. Again 13 is there, but 14 is not there. So, I will multiply here in the denominator by 14. So, in the denominator also I will multiply with 14. Again 15 is there, but 16 is not there. So, I will multiply by 16 in both denominator and denominator, and then 17 is there, but 18 is not there. So, then again I will multiply at both places. Then 19 is there, 20 is not there. So, I will multiply here by 20, both places, and then 21 is already here. So, now this will become, after factorial 8, 9, 10, 11 till 21 is there. So, in the denominator it will, this complete thing will become factorial 21, and in the denominator it is factorial 8, and then I will take 2 from each one. So, 1, 2, 3, 4, 5, 6. So, it will be 2 to the power 6 into, then it will become sorry, yeah. So, it will become 5, it will become 6, 5, 6, 7, 8, 9, 10. Okay. But 1 to 4 is missing. So, I will multiply here by 4, in the denominator also I will multiply by 4, and then it will be 1 into 2, sorry, not 1 into 2, it starts from 5, 5 into 6, because 2 I have taken out, 5 into 6 into 7 into 8 into 9 into 10. So, this will be equal to factorial 21 multiplied by factorial 4 divided by 2 to the power 6 into factorial 8 into, this will be factorial 10, because till factorial 4 is here, then 5, 4, 6, 7, 8, 9, 10. So, this will become factorial 10. So, this multiplication in the factorial terms, it comes out to be this. Now, suppose you have to solve a problem where it is given that factorial n plus 2 is equal to 30 multiplied by factorial n. How will you solve it? So, this we can write n plus 2 into n plus 1 and again n. So, it will we can write factorial n is equal to 30 factorial n. Factorial coming both sides, so we can cancel it out. So, and then we can expand it. So, it will become n square plus 2n plus n plus 3n plus 2 is equal to 30, which will be equal to n square plus 3n, and this 30 comes this twice. So, this will become minus 28 is equal to 0. So, it is simply factorization we will do. So, this will become n square plus 7n minus 4n minus 28 is equal to 0, and this will give n outside n plus 7 minus, if I take 4, n plus n will, this is equal to 0, and then this equation becomes n plus 7 I take common. So, it will be n minus 4 is equal to 0. So, the sum of these two factors are 0. So, either n will be equal to minus 7 or n is equal to 4. N is equal to minus 7 or n is equal to 4. Since n is the element of natural numbers, so n minus 7 is not possible. So, the value of n will be this one, n is equal to 4. So, this is how you can solve the problems based on factorials. I will take one more quick example. Suppose it is given that factorial n minus 2 is equal to 12 multiplied by factorial n minus 4. So, how will you solve it? It will become n minus 2 into n minus 3, again n minus 4 till 1. So, we write it factorial n minus 4, because n minus 4 is here also. So, this will cancel out, will be equal to 12 n minus 4, and factorial n minus 4 both sides in multiplication. So, it will cancel it out. So, this will become n square minus 3n minus 2n. So, it will become minus 5n plus 6 is equal to 12. So, this will be n square minus 5n, and this will become minus 6 is equal to 0. So, again if you solve it, so this is 6. So, we can write it n square, simple factorization, minus 6n plus n. So, this will come minus 5n, minus 6 is equal to 0. This will give, take n common here, n minus 6 plus 1, n minus 6 is equal to 0. So, n minus 6 take common here, n plus 1. Since these two factors coming out to be 0, so either this will be 0 or this will be 0. So, n is equal to 6 if this is equal to 0, or n is equal to minus 1. This is not possible because n is an element of natural number. So, n is equal to 6 we will take. So, this is possible. So, the value of n will come out to be 6. So, that is how you can solve the problems based on factorials, and this will be used in your permutation and combination problems which we are going to learn in the next classes. Okay. So, friends, today we have covered the fundamental principles of counting, that is fundamental principle of multiplication and fundamental principle of addition, in which if you have to do n jobs and each job can be done in distinct number of ways. So, FPM, that is fundamental principle of multiplication, says that all the n jobs can be done in succession in M1, M2 till Mn. If you multiply all the number of possible ways for each job, then it will give the total number of ways in which we can solve the problem. The fundamental principle of addition says that if one job is to be done out of n jobs, then and if each job is being done in M1, M2 till Mn number of distinct ways, then the total number of ways in which 1 out of n jobs can be done is equal to M1 plus M2 plus M3 summation of all the ways. So, this will give the fundamental principle of addition, in which you add the number of ways of all the options. Thank you.